Welcome to EDU World Space.
So this problem tells us that there is a constant electric field pointing in the negative x-hat direction. So we want to draw it, and then we want to have a nice little coordinate system here, just so that we can kind of visualize what's going on. And this constant electric field is everywhere in space. And then we're considering 2 points. So there's point A and point B. And we know that point A is at 0.6 meters, and point B is at 0.9 meters. And then we know the voltage between these two is 240 volts. So this is our setup. And now for part A, we have to find out whether the voltage at B or the voltage at A is higher. So we can see that the electric field is equal to negative the gradient of voltage, or this just tells us that E is equal to negative delta V over delta X, since we have a constant electric field here. So this tells us that we have negative V final minus V initial over X final minus X initial. So if we're considering 2 points, we could consider point B minus point A, okay? So the electric field would be equal to minus VB minus VA over XF minus XI. Well, the bottom is positive because B is at a bigger X. So this is a positive, and then we have a negative times, and we want to figure out whether this VB minus VA is positive or negative. Well, the electric field is pointing in the negative direction, so that will take care of this negative here. So therefore, the thing inside the parentheses better be positive. So therefore, VB is greater than VA, just by making a sign argument. Okay, so that answers part A. The voltage at point B is higher than the voltage at point A. So now we want to actually use what we just figured out to calculate what the magnitude of the electric field is. So the magnitude of E can just be equal to the magnitude of this minus delta V over delta X. So now we just plug in what all our values are. We have VB minus VA over XB minus XA. And so we would have 240 minus 0 over 0.9 minus 0.6. So here I've just assumed that the voltage at point A is 0. Really, it's just the difference between B and A is 0, because that was told in the problem. So when you plug this in, you'll find that the magnitude of the electric field is 800 volts per meter. So moving on to part C, we now want to figure out the work done on a particle. So we have this new charged particle Q equal to negative 0.2 microcoulombs, which is negative 0.2 times 10 to the negative 6 coulombs. We want to calculate the work from point A to point B. So the work is equal to negative delta U, which is just equal to negative U final minus U initial, which is just going to be UB minus UA. Now these are potential energies, but we only know about the potentials. So we can change this to our charge times VB minus the charge times the potential at point A. So this just tells us that it is Q times 240, because VB minus VA is 240, The charge here is negative, so when we plug it in, we get that the work done is just negative 4.8 times 10 to the negative 5 joules. And that's your total work done.